In our previous video, we talked about the unit of measurement. We talked about SI base unit, derived units. Now we are talking about the numerical value of the measurements. What should we know about these numbers? We're going to talk about the scientific notation, which is a way to write the very, very big numbers or very, very small numbers. And also we are going to learn about significant figures. So what is scientific notation? So think about the mass of 12 grams of carbon. How many atoms do we have? Well, this is the number of atoms we have in 12 grams of carbon. So this is a very, very large number. We can use scientific notation to make it smaller. So in scientific notation, we put a decimal place right after the first number from the left, the first non-zero number. Okay, so 6 is our first number, so we put a decimal place, and then we see how many digits we have in front of it. So we have 3, 6, 9, 12, 15, 18, 21, 22, and 23. So let me erase this. Yep. So we have 6.022. The rest of them are 0, so I don't need to write them because it's after the decimal place. Times 10 to 23. So it's just 6. It's not a very good 6. So it's 6.022 times 10 to 23. And it's basically 10 times 10 times 10, and it's going on for 23 times. Okay, and if you do that, you will get the same number. So it's a same number. This is how we write it in the scientific notation. So you see, it's easier to write it. There is no way you can put this number in a calculator, but you can use your calculator to put this number in. Okay, so this is a very, very big number. This also can be used for small numbers. So think about the mass of a single carbon atom. So a single carbon atom have this mass in gram. Okay, so again, to write it in the scientific notation, you put a decimal place after the first non-zero digit from the left. Okay, so 1 is our first non-zero digit. So let me erase that. Okay, so we put a decimal place after 1, and that will be 1.99. so you can see how you can count how many decimal places you moved on. So it's 1, 2, 3, 4. So it's times 10 to, it's 23. So you didn't want to hear me counting, so I just paused and counted. So it's the decimal place moved 23 digits until it reaches 1. So since we are moving from left to right, that become a negative exponential. So it's 23 digit, but it's a negative exponent. Okay, so for basically in scientific notation, you have n, and this n is a number between 1 to 10. It cannot be 10, it's between 1 to 10. So the first digit is something from 1 to 9. That makes it a number from 1 to 10, between 1 to 10, times 10 to n, and this n is a positive or negative integer. Okay, if it's a very, very big number, like our first example, the exponent, that's what we call it, the exponent is a positive number. If you're talking about a very, very small number like this one, we have a negative exponent. Okay, so this n is a negative or positive integer. Now that we know how to write in scientific notation, it's good to review some basic math. You can find this information in chapter 0 in the book. And well, you probably don't even do this. You can use your calculator, but it's helpful sometimes if you know how it works. Okay, so if you want to add, this is for addition or subtraction. Okay, if you want to add two numbers in scientific notation, the first step is to write each quantity with the same exponent, with same n. So think about these two numbers. We have 10 to 4 and 10 to 3. Okay, so in the first step, we have to make both of them with the same exponent. So we keep the one with 4 and make this 10 to the 4. So we make this 3 to 4, so we have to move the decimal place one digit to the back. Okay, so that makes it 0.39 times 10 to the 4. It would be okay if we keep 10 to 3 and make this 10 to 3. In that case, we have to move the decimal place in the other direction. So it would be 43.1 times 10 to 3. Then we can add these two. Both of them should be the same thing. Okay, so now that we have both of them as 10 to 4, now we can add these two together. That makes it 4.70, and then we can write 10 to the 4. Okay, if you would do this one, you would have 47.0 times 10 to 3, and as you can see, it's the same answer. So if you move the decimal place to the back, it's 4.70 times 10 to 3. Okay, so that's addition or subtraction. So for addition or subtraction, you have to make the same exponent, 10 to the power of the same number, and then you can add the first number together and keep the 10. Okay, so what do we do for multiplication or division? For multiplication or division, let's have an example. So 2.3 times 10 to 4 times 4.1 times 10 to 2. Okay, so when you have multiplication, the power of the 10, you can add them together. Okay, so you will have 2.3 times 4.1. Okay, and these two, so you have 4 and 2, so you can add them together, and then you have 10 to the 6. Okay, and then you can multiply these two. Well, I don't have my calculator with me, but you can find the answer. Okay, what matters is this 10. Okay, if it's a negative, like 4.3 times 10 to 3 times 1.6 times 10 to negative 2. Okay, it's the same thing. Still, you can have the number here, 1.6 times, okay, so you have 10 to negative 2 and 10 to 3. Again, you add them, but since this is 3 and negative 2, the addition will be 1, right? So it's 10 to plus 1. Okay, and then you can multiply these two. So in addition, in multiplication, you add the exponent. Okay, if you have a division, so let's think about a division like in a ratio form. If you have, let's have these two same numbers, so 4.3 times 10 to 3 and 1.6 times 10 to negative 2. So you have to know this, that if you move something like the 10 to the top, you flip the sign. So this is basically 4.3 times 10 to 3 times 10 to, now it's plus 2 because you're moving it to the top. Okay, it's plus 2, and 1.6 is still here. So now it's multiplication, you can just add them, or simply just subtract them. In multiplication, you add the exponent. In division, you subtract the exponent, okay? But this is, sometimes it's helpful to know that if you take something up, you flip the sign, or you take something to the bottom, to the denominator, you flip the sign, okay? And then you can add them. So you have 4.3 over 1.6 times, so it's 2, 3 and 2, so it's 10 to 5, okay? So this was a review for how we can do multiplication, division, or addition, subtraction on the scientific notation number. We should also know the reliability of our measurement. So when you're reading a measurement on something like a burette or a graduate cylinder, scientific measurements are reported so that every digit is certain except the last, which is estimated. What does that mean? So think about a burette. You can see when you fill up with the solvent, it forms a meniscus. So, and that's what we form. If we can zoom in. Okay. So if we zoom in, it forms the meniscus here. Okay. So to read this, we know it's 4. Okay, so this is 4.1, 4.1, 4.2, and this is 4.5. You see the bottom of the meniscus is somewhere between 5 and 6, okay? So we know that, let me zoom it out. Oops, okay. So we know it's 4.5, but it's not 4.5, it's not 4.6, it's somewhere between 4.5 or 6. So the last digit is always an estimate, okay? So I see it as 7, you might see it as 8, or you might see it as 6. I think it's 7. So the last digit is an estimate. So it's 4.57. It's the same thing when you're reading a temperature on a thermometer, for example. So if you see this thermometer, so this is 100, 101, 101, 2, 3, and it's between 3 and 4. So we know it's 103, and well, I say it's 4. You might say something different, but I think it's 0.4. Let me zoom it back. Oops, it's not good. Okay, so 103, and the last digit is something that you estimate. It's 100.4. So the number of the digits on the reading of the measurement, it's important, okay? So that's what leads to seeing what digits are important, and that's what is called significant figures, okay? Significant or important figures, important digits. So we have to know which numbers are important and which number are counted as significant figures. So what is significant figures? It's important to know about the significant figures because sometimes you put the numbers in the calculator and it gives you a long list of digits, and sometimes you think that it's better to keep all of them, but it's not. You think if you drop them it's less accurate, but actually it's not, because those numbers are not significant, they're not important. So what are significant figures? So when you have a number, any non-zero digit is a significant figure, and we are talking about the measured value, not something that you have in that we were just talking about the numbers in the calculator. You would say, okay, these numbers are not 0, so it should be important. No, this is something else that we are going to talk about it after this step. So we are going to talk about what significant figures do we have in multiplication, division, in addition or subtraction. Okay, if you're given a number and you want to see how many significant figures you have, okay, so any non-zero digit is a significant figure. Okay, so how many significant figures do we have here? there is no 0, so we have 4 digits, we have 4 significant figure. Okay, what about if it's a 0? Well, are 0 significant figures? It depends. Okay, so the first type of 0 are zeros between non-zero digits. Okay, or sometimes they call it sandwich zeros. Okay, sandwich zeros. Are sandwich zeros significant figure? Yes, they are significant figure. So if you have a 0 in two non-zero digit, you count it as a significant figure. So this number, how many significant figures do we have? We have 3 sig figs. Okay, we have 1, 2, 3. This 0 is between two non-zeros, so it's a significant figure. So you have 3. The second type of zeros are the zeros on the left of the first non-zero digit. Okay, these are called leading zeros. Leading zeros. Are leading zeros counted as significant figure? No, they are not significant. Okay, so if you have a number like this, how many significant figure do you have? You have only 1 sig fig. Okay, you don't count these zeros because these are leading zeros. You only have 1 non-zero digit, so you have 1 sig fig. Okay, the last type of zeros are called trailing zeros. Trailing zeros are zeros that come after a non-zero digit. Are trailing zeros counted as significant figures or not? Well, it depends. Okay, if you have a decimal point anywhere in the number, the zeros, the trailing zeros are counted as significant figure. And it doesn't matter if the 0 is before the decimal point or after the decimal point, it doesn't matter. We still count them as significant figure. So for this one or this one, both of them have 4 significant figures. We have 2 trailing zeros. In here we have both of them after the decimal point. In here we have 1 before and 1 after, but it doesn't matter. We have 4 significant figures. Okay, so in the last example, sometimes it becomes ambiguous. Like, look at this number. Okay, how many significant figures do we have? So we have trailing zeros and there is no decimal point. So if you don't see any decimal point, you should say it has 2 sig figs, right? But you don't know. Sometimes it's ambiguous. Maybe the measurement was true to the third sig fig. Maybe it was true to the last sig fig, to the last 0, like 6 sig figs. So if you want to write this with a 6 sig figs, we can put 1 decimal point in the end, and that makes these zeros as significant figures, so we can count them as a significant figure. In this case, that would be 6 sig figs. But the best way to report the actual number of significant figures is to write this with scientific notation. So if I know that this number is true to the third sig fig, I can write it in scientific notation as 3.20 times 10 to 5. Yes, we have 5 digits, so 10 to 5. So now we have 3 sig figs. Or if I know it's true to the 4 significant figure, so I can write it with 1 more 0. That makes it 4 significant figures because we have a decimal point. Okay, so these numbers is a little bit ambiguous. So if you're given this number without the decimal point, let me erase this. So if you're given this number without the decimal point, you would say it has 2 sig figs because the rest of the zeros are trailing zeros and there is no decimal point, so only 2 sig figs. Okay, so now you should be able to tell me how many significant figure each of these have. Okay, so tell me how many significant figures the first one have. So if you said 2, you're right. We do not see the exponents, okay? It just tells me how big the number is, okay? So this number tells me how many significant figure do we have, and we have 2 digits, so it's 2 sig figs. What about this one? How many significant figure do we have in the second? So if you said 2, that's true. We have 1 trailing 0, and we know the trailing 0 without a decimal point is not counted as a sig fig. So we have 1 and 2 significant figure. So if we want to show it with 3 sig figs, how do we write this? So we can write it either like this with a decimal point, or we can write it in the scientific notation. So it's 5.6 with 3 sig figs. So let me erase this. So 5.60 times 10 to 2, okay, kilogram. So seems like this time writing with scientific notation makes it even longer, but I mean, if you want to show it with 3 sig figs, that's how you can write it. Okay, how many sig figs these 3 numbers have? So the first one, I don't know what's wrong with this today, sorry. So with this one we have 2 digits, so it's 2 sig figs. This one we have sandwich zeros, so we count them as a significant figure. So it's 1, 2, 3, and 4. This one has 4 sig figs. And the last one we have leading zeros. We know that leading zeros are not significant, so we count them as 1, 2, 3. So we have 3 sig figs here. So in our last slide, we are going to talk about exact numbers. So in next video, we are going to talk about how these sig figs are important in addition and multiplication, addition, subtraction, multiplication, division, and sometimes that become an issue. So first we have to know what is an exact number. Exact number, from definition, is a number that has infinite number of significant figures. How? What does that mean? So when we say, for example, we have 5 students, okay, this 5 is the exact number. So it has infinite significant number. Why? Because I can say 5 students, I can say 5.00, I can say 5.000, and that can go to infinite numbers, okay, because that's an exact number, okay. So exact number is a number that can have infinite significant figures. So in examples like this, like if you want to get an average of these 3 numbers, okay, so you add these 3, that's how you get an average, and divide it by 3, okay. So if you want to, we will learn about this in the next video, but if you want to follow the significant figure, we should say, okay, this is 1 sig fig, so your answer should have 1 sig fig, so therefore it should be 7, because for 1 sig fig, since it's a 6, we round it up, it makes it 7. But it's not right, because this is an exact number, so we do not look at the exact number in our calculation. So each of these two have 2 decimal place, so the right answer should be 6.67, not 7, okay. We will talk more about addition and addition, subtraction, and multiplication, division in the next video.